In this video, we will demonstrate the relative performance of Optimum P2P against GossipSub. So GossipSub is a very well-known, well-established peer-to-peer protocol for gossiping. And Optimum P2P is a new protocol that does a similar functionality and which is based on random linear network codes. So the main functionality of this protocol is that you publish some message on a node and it can be subscribed by any other node on which you receive the message. So in our setup, we compare these two protocols with 72 nodes in total that are distributed across the globe. So for GossipSub protocol, we have 36 nodes. And similarly, Optimum P2P based protocol is deployed over another 36 nodes. Then we will look at the size of the message we publish and also the rate at which we publish. For example, we have here a diagram and geographic distribution of these nodes. So we have these nodes, for example, in Optimum P2P from North America, Europe, and Asian countries, including Australia. Similarly, we have another set of nodes. So these are almost nearly identical, near distribution of these nodes. So now we are going to run some tests. Now let's look at the various parameters. So here on top, we show you a random topic. It's prefixed by a custom topic. Size of the message that's being published, it's about 5 MB, given that most of the block sizes in different L1 networks are of approximately 2 to 5 MB large. And then we'll be publishing at a rate of 1 random message per second. And we are going to see we have two plots here. On the left, it will show you the latency of the Optimum P2P based gossip. And on the right, we will have the GossipSub. So now the latencies are in milliseconds. And so we will have average delay. So now what does it mean by delay? So a delay of a gossip is that approximately almost all, in this case, 95% of the nodes receives the message that are published. And in this experiment, we'll publish the same message to both the networks to some randomly picked node. So each message will originate from a randomly picked messages from all the nodes, from any of the nodes spread around the globe. So let's start with this. As we see that so far on the left, 7 messages has been published or 8, and then how many are delivered. That means how many have been delivered to at least 95% of the nodes. And as you can see that the average latency of the Optimum P2P delivered messages or gossip are much lower. So which is about close to about a second. On the other hand, for GossipSub, it's about 2 seconds. So now also if you note that how much variability is there or consistency of delivery. See that for Optimum P2P, it's 1/5 or 1/4 of a second, and for GossipSub, it's almost half a second. So next, we will change the size of the message. Increase the message size from 5 MB to 8 MB, and also we will double the rate of publishing. So that means every second, there will be 2 messages published from 2 randomly picked nodes around the world. So let's start the experiment. And as you see, it's beginning to deliver the messages. And as you see, Optimum P2P network is delivering messages as they are published, whereas in GossipSub, we see a lag. Of course, so far it's getting through, but the lag is getting bigger. And also, the average latency of Optimum P2P has slightly increased to over by 300 milliseconds more, whereas on GossipSub we see it's continuously increasing, and that is because it's not able to keep up with the delivery of messages with respect to the rate of publishing. So essentially, there is a delay that's building up. So the more you publish at a faster rate, more likely you will have higher and higher delays. So now we have seen through these experiments that Optimum P2P protocol performs well under larger messages and a faster rate of delivery compared to Gossip Hub. And it has a much higher performance compared to Gossip Hub.